Hi, my name is Ethan Hutzler. I'm going to be a junior in fall 2026, and I want to be a ULA. Fun fact about me is that I am a triplet, and I want to be a ULA because genuinely want to help students just do better in class and just make it easier. I know it can be really stressful. Um, and I also think being a ULA is a great way to build a relationship with a professor. And a specific study strategy I would recommend to students is to go to the ULA sessions every single week. Even if you don't have time, just stop by and grab a sheet because the practice questions on the ULA sheets are really helpful and you can't get those anywhere else. So, thank you. All right, so this question gives us a conjugated diene and asks us to predict the major products with two different reactions with one equivalent HBr reacted at a low temperature and then reacted at a high temperature. So let's start with the low temperature. Since this is negative 78 degrees Celsius, we know that is going to favor the kinetic product, which is a product that goes through the most stable carbocation. So draw the basic structure and we look at the two double bonds. We know that if this top double bond were to react, it has the possibility of forming two secondary carbocations, but if this bottom double bond were to react, it could give us a secondary carbocation or a tertiary. So looking at these, we know that tertiary carbocation is going to be the most stable one possible. So we're going to have this carbocation form, and then the nucleophile is going to attack this carbocation. And since it's going by way of a carbocation, which is sp2, trigonal planar flat, right? So this could attack from the top or the bottom. So we can have two major products. You have the possibility of the methyl being out of the page on a dash and the bromine being towards us, or the opposite configuration, which is, let me get myself room here, oops, which is the bromine away from us and the methyl on the dash. And we're leaving this top double bond untouched because there's only one equivalent HBr. And that is going to be known as our kinetic product because it's formed the fastest. But it's not the most stable alkene that we could possibly form, as we'll see over here when you increase the temperature. So you start off by just knowing that one double bond is going to be reacting. And if you were to have the same carbocation, you can look and say that this double bond is not actually the most stable, right? Because it's only di-substituted. You only have one, two substitutions on it. And the most stable alkene formed would actually be tri-substituted, right? So if you had resonance, you know that this double bond would go here and the carbocation would form up here, which is what we're going to have. And then the bromine could now attack at this top carbocation, right? And this is also known as the 1,4 product because essentially in this first step, when the double bond breaks, you're going to have a hydrogen added down here, which is going to be, if you call that the one carbon, this would be 1, 2, 3, 4, where the bromine is added. So this is the 1,4 product, and it would lead to the most stable product. And if you were to draw an energy diagram, you would see that this has a greater activation energy than the kinetic product because the carbocation is less stable, right? So that means it has higher energy, but it's going to lead to a lower energy or a more exothermic reaction, making the product more stable. So that's going to be our product. And if we were to look and see if we had resonance here, or not resonance, if there's a chiral center, we know there is actually a chiral center. So once again, you can have the Br going away from you, or the bromine could be wedged towards you. So once again, you have two products formed here, and this product is more stable than the kinetic product. So thank you for listening to my question and for considering me as a ULA.